Hi, so what we've got here in this one is this integral 4 sine x cosine x all divided by 1 minus cosine squared x plus sine squared x, and we're integrating this with respect to x. So if you'd like to have a go at this, as usual, just give you a short while to pause the video. When you come back, you might want to fast forward if you want to check your answer, or I'll take you slowly through the work solution. Okay, welcome back then if you had a go. Let's see how you got on. Don't forget, you can fast forward if you wish to see how I worked out the solution. Check yours against mine. Now this is an interesting problem because there's two ways, for instance, that you could do this, and I'll show you both ways, and it raises an interesting point about constants of integration. So let's just take this one at the moment, okay? What I notice is that we can simplify this first of all. Should be familiar with 1 minus cos squared x. It comes off the identity sine squared x plus cos squared x is identical to 1. So you could actually change this to sine squared x, okay? So if you were to do that, you're going to get this, okay? 1 minus cosine squared x is sine squared x. Add it to the sine squared x here, and you're going to get 2 sine squared x in the denominator. And what happens is that we can cancel out the 4 and the 2. 4 divided by 2, that's going to be 2. And we can cancel out the sine x here with the sine squared x in the denominator, just leaving us with this integral. 2 times cosine x all over sine x. Notice how I've pulled out the 2 in front of the integral because it's a constant and it's a factor of this. Okay, so we can do that, and then whenever you get a fraction in an integral, always check to see whether differentiating the denominator gives you the top, because we can then apply this rule here. Whereas if you've got some function of x in the denominator, and if you differentiate it and it appears in the numerator, then it's going to be equal to the natural log of the modulus of that function of x that you've got in the denominator here, plus your constant of integration, of course. Okay, so we have that here. Differential sine x is cosine x. Okay, so it lends itself to this type of integral. And so if you do that, you're going to get this equaling 2 times the natural log of the modulus of sine x plus the constant of integration, c. Now you could leave it like this, or you might want to use the power rule for logs. That is, that we can take this 2 up as sine squared x, okay? Sine of x all squared, same as sine squared x, okay? And if we write that, okay, we get this result here. And notice how I've removed the modulus sign. We don't need it here because if you were to square any function, it's going to be a positive value, okay? So the natural log of sine squared x plus that constant of integration c. All right, so any of these two answers would do. Now I did say that we could look at this integral in another way, okay, and it will raise an interesting question at the end. So what way was this? Well, I noticed that the top and bottom look very similar to working with these identities. If we were to look at the sine of 2a, okay, this identity here should be familiar, is identical to 2 sine a cos a. And if I was to replace the a with an x, okay, we've got sine 2x would be identical to 2 sine x cos x. And that's in here, okay? And I also know that the double angle cosine 2a is identical to cos squared a minus sine squared a. You'll see these identities generally in your formula book. If not, you should be aware of them, okay? And again, if I replace the a with an x, you can see that this looks to resemble something like this, okay? Now, if I was to rewrite the integral, okay, in this form, that 4, think of it as 2 times 2, okay, 2 times 2, and then we've got sine x cos x. You can see that's got this look here. And if I was to pull out -1 as a common factor across these two terms, I could put this in a bracket, okay? We'll end up with 1 minus all of cos squared x minus sine squared x, and that is going to be this identity here, where we've got cos squared x minus sine squared x, it would be cos 2x. So if I sub in those identities, I can rewrite this integral, okay, as sine 2x all over 1 minus cos 2x, okay? Now, I notice that I can use this idea up here. I can see that if I differentiate the denominator here, 1 minus cos 2x, what I'm going to get is simply 2 sine 2x. And I've got that here, 2 sine 2x. So this is the same then as the natural log of 1 minus cos 2x in mods. And then I've written plus k. Normally, if this was not here, and I was just doing this integral like this, I'd write that as plus c. But because I've got them on the same page, okay, I've decided to show this as plus k. Why? Because they're going to look different, okay, different answers. I'll be suggesting that 1 minus cos 2x would be the same as sine squared x, okay, and that's not necessarily the case, as I'll show you. I could also rewrite this then 1 minus cos 2x. Remember, 1 minus cos 2x up here, okay, was the same as this result here. And we saw that this result, 1 minus cos squared x was sine squared x, from here could be written as 2 sine squared x, okay? So this answer here could be written, okay, as the natural log of 2 sine squared x plus that constant k. And again, notice here that I've not written this in mod signs, okay? You can if you want, but it's a bit pointless because this will be a positive quantity, okay? Now, why would this answer then be different, okay, from this answer, or it appears different, okay? Well, we can see why our constants have to be written differently if we're presenting them on the same page. And that's because of this, okay? Let's show you, all right? We've got, if they were to be equal, that is, the natural log of 2 sine squared x plus k, this answer here, is equal to the one up here, the natural log of sine squared x plus c. Now, if I was to rearrange this, okay, take the natural log of sine squared x from both sides and k from both sides, we're going to get this line here, okay? And then, using the subtraction rule for logs, okay, I can rewrite this as the natural log of 2 sine squared x all divided by sine squared x, and that's going to equal the difference between the constants c minus k, okay? And then this simplifies, okay, just leaving us with the natural log of 2. So if I make k the subject, can you see k would equal c minus the natural log of 2. And what I've got here is two constants. Natural log of 2 is a constant value. Two constants being subtracted, okay? C minus another constant is going to give us another constant. And so that is why the answers appear different, but yet are the same. Okay? So I hope you've been able to see your way through that question. Appreciate the connection between these constants if ever you're asked to demonstrate why these solutions are effectively the same. Okay? And that leaves me just to say, if you like this video, do give us a like, and you might want to subscribe to get further notifications on any more videos that I put up. And thanks for watching. Hopefully see you in another video. Bye for now.